Okay, welcome back, everybody. We're going to be talking in this lesson about parallelograms and properties of parallelograms. We're going to have a definition of what a parallelogram is. We're going to have four theorems revolving around parallelograms, and we're going to prove those, and then we're going to conclude with a couple of examples. Okay, so first of all, what is a parallelogram? Parallelogram is a quadrilateral, so four sides with two pairs of parallel sides. So in this figure, your left side and your right side are parallel, A, B, and C, D, as well as your top side and your bottom side. So BC is parallel to AD because that's a parallelogram. We're going to start out right away with the first theorem regarding a property of parallelogram. So that theorem says that opposite sides of a parallelogram are congruent. So if you look at the figure there, you got quadrilateral JKLM is a parallelogram, that's given. And you're trying to prove that JK and LM are congruent, left and right sides. And you're also trying to prove that KL and MJ are congruent, top and bottom sides there. So we already know from the given, this is statement one, so we're back to two-column proofs here. So we're given that JKLM is a parallelogram. That's going to be the symbol for a parallelogram. It's kind of nice. It's shorter to write. So the reason for that is given. We know then that JK and LM, the left and right sides, are parallel. That's your statement number two, as well as segment KL and MJ. They're parallel simply because that's what a parallelogram is. So definition of a parallelogram. Okay, so now in statement three, we can say angle one is congruent to angle two. So we got this angle and this angle congruent because you see two parallel lines here cut by a transversal. So the left and right sides are the parallel lines. So it's the alternate interior angles theorem. And you also see angle 3 congruent to angle 4 by the same theorem, which will show you a different pair of parallel lines. So there's your parallel lines, and there's your transversal. So you get that letter Z again, and so 3 and 4, those angles are in that letter Z. So we have, by the same theorem, the alternate interior angles theorem there. Okay. So we can also mark off in the diagram segment JL is congruent to itself by reflexive property. So that's statement and reason number 4. And then if you look at those two triangles, the top and bottom triangle, they are congruent by angle, side angle. You can see angle included side angle in both of the triangles. Actually congruent by rotation there. And then because those two triangles are congruent, now we can use corresponding parts to say that JK, so left side, is congruent to LM. So JK congruent to LM, and also the top and bottom, so KL congruent to JM, because those are corresponding parts, and so corresponding parts of congruent triangles are congruent. So that proves the theorem that opposite sides of a parallelogram are congruent. Okay, we also have the theorem that opposite angles of a parallelogram are congruent. So there you see a parallelogram, top and bottom sides are parallel, left and right sides are parallel. We're going to prove that opposite angles are congruent. So you see what we're trying to prove there. Angle A is congruent to angle C, and angle B is congruent to angle D. So the way we're going to prove that is I'm going to draw a diagonal in here from A to C. And then you're going to see that that diagonal is congruent to itself. We know from the previous theorem that opposite sides of a parallelogram are congruent, so we know that these two sides are congruent, as well as these two sides, left and right sides, because again, the previous theorem, opposite sides of a parallelogram are congruent. So you see that these two triangles are congruent by side, 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 SSS. Okay, so now then we can say that angle A, actually we're doing this part first, we can say that angle B is congruent to angle D by CP/CTC. Because once those two triangles are congruent, all their parts are congruent. So corresponding parts of congruent triangles are congruent. So we've got angle B and angle D congruent. Now if I erase my markings here and draw a different diagonal, we can prove the other part. Okay, so if I draw this time my diagonal like this, we're basically going to have the same proof. That segment's congruent to itself. Segment on the left, AB, is congruent to CD because opposite sides of a parallelogram are congruent, and also the top and bottom are congruent for the same reason. Opposite sides of a parallelogram are congruent. So same thing here. These two triangles are congruent now by side, side, side again. Same reason as before. And now we can look at angles A and C and say that they are congruent for the same reason. They're corresponding parts of congruent triangles, so they are congruent. So now we know that opposite angles of a parallelogram are congruent as well as opposite sides. Okay, third theorem. We got 4 today. Third theorem. Consecutive angles of a parallelogram are supplementary. So consecutive angles, you might remember, mean next to. So A and B are consecutive angles, B and C are consecutive angles, C and D are consecutive angles, and D and A are consecutive angles. So we're going to prove that they are supplementary. Okay, so given, first statement, ABCD is a parallelogram. It's part of the given. You can see that by the markings also. Statement number 2, AB is parallel to CD, so the left and right sides are parallel, as well as BC and AD, top and bottom. That's by definition of parallelogram. Okay, now, statement number 3, which is actually the last statement, has 4 sub-statements in it. They all share the same reason. So as we kind of go around the parallelogram, you'll see what we're talking about. The reason for all these statements is if 2 parallel lines are cut by transversal, then same side interior angles are supplementary. So our first statement, angle B is supplementary to A. So these 2 angles are supplementary using the top and bottom sides of the triangle as parallel, and then BA would be the transversal. So A and B would be same side interior angles. So they're supplementary. C and D, same thing over here. Top and bottom are parallel. This is your transversal. C and D would be same side interior angles, so they're supplementary. Now pick B and C on top. Same thing, but different parallel lines here. So now the parallel lines are going to be the left and right sides, and BC will be the transversal. That'll make B and C same side interior angles, and so the theorem says that they're supplementary. And likewise, at the bottom here, angles A and D, same thing. If you consider the left and right sides of the parallelogram to be the parallel lines and AD to be the transversal, then A and D are going to be same side interior angles, and so they're supplementary by our theorem. So our third theorem regarding parallelograms are that consecutive angles of a parallelogram are supplementary. Okay, our last theorem today is that the diagonals of a parallelogram bisect each other. So you see the parallelogram ABCD, top and bottom are parallel, left and right sides are parallel. That's what a parallelogram is. Then we're trying to prove that BZ, so you see, first of all, you see the diagonals are BD. BD is a diagonal, and AC is at the other diagonal. They go from corner to corner there. So we're trying to prove that those 2 diagonals bisect each other, cut each other in 2 congruent pieces. So we're trying to prove that BZ and DZ are congruent. That would make BD get bisected. And we're also trying to prove that AZ and CZ are congruent. That would make AC get bisected. Then that would be the proof. Okay, so look at the diagram here. We got ABCD as a parallelogram. That's part of the given, right? Starting with parallelogram. We're saying that the left side AB is parallel to CD. Well, the left side and right side are parallel by definition of a parallelogram. Okay, now we say that angle 1 is congruent to angle 2. Do you see the alternate interior angles there? You take your letter Z here. You see that angles 1 and 2 are inside that letter Z, so they're alternate interior angles, and that makes them congruent by the alternate interior angles theorem. Okay, now let me draw that Z a different way. Same 2 parallel lines, left and right side, different transversal. So now angles 3 and 4 are inside that Z, and so they're also alternate interior angles, so they're also congruent by the alternate interior angles theorem. Okay. So I should mark those off. Okay, next step in our proof. BC segment AB is congruent to CD. So the left and right sides are congruent. It's because opposite sides of a parallelogram are congruent. We had that just a few minutes ago. Now, if you look at these two triangles, they're telling you that this triangle is congruent to this triangle. That's what we're saying in statement number 5. So triangle ABC, that yellow one on the left, congruent to CDZ, that one on the right. So those are congruent. How? By angle, side, angle. You can see you got angle, side, angle in the yellow triangle, angle, side, angle corresponding in the blue triangle. So those two colored triangles are congruent. They're actually congruent by rotation. And so that tells you that, I'm going to mark this off, that this piece is congruent to this piece because those are corresponding parts of congruent triangles, so they're congruent, as well as this piece. Oops, let me use 2 there and then 3 here. Those two pieces are also congruent because if you rotated the blue one around to fall on top of the yellow one, they would be corresponding parts, so they're congruent. Corresponding parts of congruent triangles are congruent. Okay, so basically what we've seen then is that these two diagonals have bisected each other. You can tell that the diagonals got cut into two congruent pieces, and that's, I guess, our reason for that would be definition of segment bisector. Definition of segment bisector. So the theorem we just proved was that the diagonals of a parallelogram bisect each other. Okay, we just have 2 more examples to go, and that'll wrap it up. So both these examples deal with this diagram right here. So we're given that ABCD is a parallelogram. I should probably draw those arrows on there to show that. Okay, so we got to find side AD, length of side AD. So notice the top and bottom sides have expressions that we can set equal because now we know that opposite sides of a parallelogram are congruent. So we can say that 5x plus 19 is equal to that 7x down there. Opposite sides are congruent. So subtract 5x. So 19 is equal to 2x. So x is equal to 9.5. And remember, we got to find side AD. So side AD equals 7x, so 7 times 9.5. Let's multiply that in the calculator. 7 times 9.5 is 66.5. Okay. And our last example, so we've got to find the measure of angle D. Remember that since this is a parallelogram, angles B and A are supplementary. You got parallel lines cut by transversal. Those are same side interior angles. So those angles are supplementary, so we can write an equation for that. Remember, supplementary means adds up to 180. So 7y plus 5 plus 10y minus 1 equals 180. Those are supplementary angles. So it looks like we have 16y plus 4 equals 180. So 16y plus 4 equals 180. So we'll subtract 4, so that it's going to give us 16y. It's 176. And we'll divide. So we got 176 divided by 16. It comes out to be exactly 11. And so remember, they want the measure of angle B. So the measure of angle B equals, what was it again? 6y plus 5. So 6 times 11 plus 5. So it looks like we have 66.5 plus 5, so a total of 71 degrees for that angle. Okay, let me summarize a little bit. We had a lot to cover today. A parallelogram is just a quadrilateral with two pairs of parallel sides. And then we had 4 theorems about parallelograms that we need to remember. And the first one was that opposite sides of a parallelogram are congruent. Both pairs of opposite sides are congruent. And then the second one was opposite angles of a parallelogram are congruent, both pairs. The third property we need to remember is that consecutive angles of a parallelogram are supplementary. Consecutive angles of a parallelogram are supplementary. And then the last one that we need to remember is that the diagonals of a parallelogram bisect each other. The diagonals of a parallelogram bisect each other. Okay, that's it. So let's go ahead and put those theorems to work and work some problems. They're posted, so good luck.